Hi everybody. Happy to see you. Third day of conference, and yes, people still looking to learn some practical things. Just to make some idea, how many of you are Kotlin developers? Oh, not everybody. Okay, and if I ask how many of you are writing your own DSLs? Okay, probably not in Kotlin, but in some other languages. Nobody. Okay, the objective of my talk is turn more of you into my camp of DSL writers. So one source to rule them all, which means you have one source, which is the single source of truth for multiple tasks in your application. So who am I? I'm currently living in London and working for a company called Synthesized. Also, I'm teaching Java and computer science in a number of universities. So what I'm going to discuss in this talk. So it's 1 hour talk, quite long, and it's actually, divided into 3 parts. In the third part, I will explain what DSL is and the place of Kotlin, domain-specific languages, among all the landscape of possible DSLs, all the strengths and weaknesses. The second part will be several examples of tasks that can be solved by introducing a DSL in your program. So you have single source and you can solve multiple tasks. And the third part will be about some advanced specifics of designing Kotlin DSL. So this every next part is going to be slightly more complex than the previous one. So if you kind of lost at the third part, it's okay. What I'm not doing in this talk is basics, so basic introduction in creating Kotlin DSLs. There already were a number of good talks and resources about this. I'm going to provide you links, and actually do not worry, I think you will be able to catch up. During this talk or after this talk, actually there is no magic. It's just Kotlin syntax which is being used wisely. And also this talk is AI free. So this is probably the only time that I'm using AI term in slides or in the talk. So it's all about good old software development like it used to be before. Okay, so the first part, domain-specific languages. Well, domain-specific languages is a vast field. There is a book, a definitive book with the same name by Martin Fowler. It's that thick. It's big one. What is important is to understand what kinds of domain-specific languages there are. So they are subdivided into external and internal. External languages, it's easier. I think it's easier to define what internal domain-specific languages are. Internal, they are built on top of some general-purpose programming language, like Kotlin, or Groovy, or Ruby, or JavaScript. And external languages, they are not. They just they're not executable, first of all. So the first kind of DSLs is the DSLs designed from scratch. So they are designed just like any other computer languages, only they are domain-specific. So probably you know some of them. Graph visualization, who knows graph is? Oh, some of you, good, yeah. The rest of you will, I suggest you to look up. It's great thing. So you actually write some code and it's visualized into graphs. HashiCorp configuration language, the language designed from scratch for some specific task. Gherkin, it's behavior-driven testing framework and the special language here. I could put SQL here, but over the years, over decades, I think it transformed into general programming language. But actually, it's from the same family. The next family of DSLs are those that are based on general-purpose markup language. And of course, it's YAML nowadays. Everything is YAML nowadays, like OpenAPI, Ansible, GitHub Actions, Kubernetes definitions, whatever. It's all YAML, YAML, YAML. So you have a YAML as basis, you define schema, and you build a DSL on top of this. XML, well, it's kind of out of fashion nowadays, but XSLT, XSD, they're quite advanced languages, and they are built on top of XML. So let's go to internal languages. Internal languages, they can also be subdivided by the nature of their basic language. It's either dynamically or statically typed. So if we take a dynamically typed language, historically the first one was Lisp. So if somebody knows like Emacs, so this is historically the first internal DSL. Ruby is quite powerful, so RSpec, Chef, probably somebody is using it. So in Ruby is quite expressive for DSLs. I think the most powerful though is Groovy language, where you can do nearly everything. So you can write code which will look like your normal, English text, and it will be a code. It will be interpreted by Groovy as a language. So lots of stuff, and for JVM programmers, I think Gradle and Jenkins file must be familiar, like your Groovy DSLs that you are working with. And finally, statically typed languages. And interestingly enough, that, Java does not provide opportunities for building DSLs. C# does not. So we have either quite niche languages such as Scala or Haskell, and we have Kotlin, which is both like general purpose programming language and a programming language with features which allow us to build DSLs, which is really, really interesting. And this is, I think this is one of the most powerful features of Kotlin, and somehow overlooked, because many people are talking about Kotlin coroutines, structured concurrency. In my view, DSLs are like this also quite important feature of Kotlin, and very powerful one. Okay, let's discuss trade-offs, because when you choose whatever family of DSLs you are going to use, there always will be pros and cons, drawbacks and advantages. The main advantage from for the language designed from scratch, there is no restriction. You define your syntax. So do whatever you like. When you build something on top of Groovy, for example, you also nearly don't have any syntax restrictions. So, of course, if you open a parenthesis, you must close it. If you open a curly brace, you must close it. But in a truly dynamic language, which can handle unknown identifiers dynamically, for example, you somehow can write a code which handle it, you don't have like that much syntactic restrictions. So this is like green in this picture as well. It changes a lot when we go to things based on JSON, YAML, XML. Of course, if you are doing YAML DSL, it must be YAML, first of all. If you are doing XML, it must be XML. And finally, for statically typed languages, you are quite restricted. So it must be compilable, not only like syntactically correct Kotlin code, right? It must be compilable like statically type-checked Kotlin code. And you will face more syntax restrictions there. I will discuss them in the latest part of, in the last part of my talk, and the ways how to like circumvent them. Another thing, like we can look from the perspective, from the aspect of restrictions, but what if we think about IDE support? If you write your own DSL, there is no IDE support for this. Of course, you need to write your own plugin for all the IDEs, VS Code, IntelliJ, whatever, which is not always the case, right? So nobody is going to use your DSL probably if there is no IDE support out of the box. Same for dynamically typed languages. Of course, we do have support for Groovy, for example, in IntelliJ, but it's quite rudimentary, because in Groovy, as I said, like every text is syntactically correct Groovy script, actually. So it cannot provide you, alternatives like drop-downs, the things that we like. It will not underline with red like your mistakes. So less support. It changes, again, it changes dramatically with markup-based DSLs. Because with XML or JSON or YAML, you have schemas, and every modern IDE can help you to write YAML according to a schema. It's quite easy, and it will guide you, and it will underline with red your mistakes and stuff. And it will give you alternatives in drop-downs, but it must be YAML. And for statically typed, well, we only have actually like 3 examples: Scala, Haskell, Kotlin. We have full support in IDE. So if our IDE supports Kotlin, then you have full support for your DSL right out of the box. And this is the main strength here. From security perspective, okay, it is simple. External DSLs, they are not an executable code. Internal DSLs, they are executable code. So if you are thinking to like allow users to write their DSLs for you and provide it, like, for example, for your software, like as a service, you know, their DSLs, think twice if you want to make them internal, because it's an executable code and there are lots of like possible security breaches. This does not mean at all with external DSLs you also like safe. Google for billion laughs attack, that's an attack on YAML parsers. There are lots of attacks on XML parsers as well. So like in either case, you are not safe when you are dealing with data from untrusted sources. So, but nonetheless, of course, you are much safer with external DSLs here. So let's go to interim conclusions about like family of DSLs to which Kotlin DSLs belong to. They belong to the class of internal DSLs based on statically typed programming language. That's a very specific class. This doesn't mean that Kotlin DSLs like are DSLs at all. And this has both advantages and disadvantages. So if you want to bring a DSL to your application, to your project, the choice is always yours. Like, don't follow the hype. Like, probably you need some other decision. Probably YAML is still better than Kotlin DSL, but it's up to you to decide. Okay, before, probably I will swap my slides a bit. Before we are going to details how to build Kotlin DSLs, let's look at some of them and see the evolution of like your code, which can be which can lead you to using Kotlin DSL in your code. So this is like our starting point. And actually, this example is based on the actual work I was doing for Synthesized quite long ago. Right, so everybody, I think, has like this kind of business logic in their code, right? So you have conditions and you have some actions. So in our case, it was transformations which we had to apply on data based on some heuristics. So we had some heuristics, and based on them, on some Boolean combinations like conjunction, disjunction, this stuff, like we are going to run some transformations. So everybody starts with just if, else, if, you know, code. So what's good and what's bad about this example? Well, first of all, let's notice that this code is already quite clean, because we extracted methods here, right, for conditions and for transformations. In real life, sometimes we like mix, you know, conditions and actual actions in this if blocks, and this lead to like unreadable or unmaintainable code. So this code is already quite refactored and quite clean, and we can run it. Let me run it. We do have like okay, just main. So we can run it. What else can we do with it? We can debug it step by step. And it's actually like a good thing. You can put a breakpoint. You can see like if you are hitting this breakpoint or not. What else can you do? We can write tests, and we can count coverage, like branch coverage, and like fully covered with like every branch is covered. If every branch is covered, probably you may think that it's a reliable code. Still, we're not satisfied, right? Because it tends to grow. When it tends to grow, it tends to contain some domain-specific knowledge from domain experts who are not Kotlin developers. So it needs to be presented to them. It needs to be validated by them. So what do we do next? So normally, if we need to somehow like refactor our code, what do? We're using design patterns, like object-oriented design patterns. So let's use one, which is called strategy, and define strategies for condition and strategies for transformation, right? Let's build the object model. So rule, condition, and transformation, they are base classes, and we can just combine the objects of these classes. And we will get, after refactoring it into an object-oriented way, we will get a code like this. So now we have our code is now returns the list of rules, and you know that rule consists of, if we click here, like what is rule? Well, effectively it's a pair, right? If condition is met, run this transformation. So now we can see at least like which rules are associated with what conditions and what transformations. We also do a composition here, right? So if we like have condition 1 and condition 2, and we want to do conjunction, like logical operation, we can build a composition of them. So it's more or less clear how to write this. And as you can see, the code looks much better. And so far, it's not a DSL at all. You can even write this in Java, not in Kotlin. The only difference in Java would be new all the way for the creation of the new, like new rule, new condition, new transformation and stuff. So here, just more concise Kotlin syntax helps us to keep code cleaner, but actually there is no magic here yet. It's just a building of objects, and this can be done in Java. So what did we win? It's cleaner. Probably you can print out this code and show it to domain expert and say, is this OK with you? You see, it's not like programming code. There is no ifs, else, and stuff. You can validate. And also, our business logic now becomes the one-liner. So we iterate through all the rules. We find the first one where condition is met, and we're running the transformation. So we run this code, and yeah, we can see that some like transformation. Oh, come on. Transformation is run, right? Transformation be invoked. OK, some of the rules won. But what did we lose here? We no longer can put a breakpoint on the code. Our test coverage, line coverage, is going to be 100%, regardless of the coverage of tests. So actually, this is a big drawback of this approach, and you must be very careful here. And if you are going that way, we need somehow to compensate. I will show you later how to do this. Well, now time has come to show Kotlin DSL in all its glory. So actually, the same code of creation of list of rules in Kotlin syntax can be represented like this. And yeah, it looks like your Gradle config, or probably some CI config or whatever. It looks like not like a Kotlin language. It looks like a specific language. And yes, this is the DSL, which is defined within the Kotlin syntax. Yet it is a correct, syntactically and semantically correct Kotlin program, which actually invokes a method here. So rules is just a function. This function takes lambda with receiver as its only parameter, which means that parentheses here are not obligatory. So I can put them, and it will be a correct function call. But I can remove them as well, and it's still going to be a correct call of function in Kotlin. So what's the magic here, like with these invokes? Invokes is still a function, but it's infix function. Infix means that it's not necessary for me to use parentheses here and use dot here, but I can if I like. I just don't have to. It's just, okay, no, like it must be a parenthesis here. Like dot and parentheses are not obligatory for infix functions, thus they can work as a verb, as some keyword in your code, DSL code. So this is something that definitely can be printed out and shown and like worked through with domain experts. This is definitely declarative code, not imperative code. And like this is where you can turn into what you can turn your internal APIs in Kotlin projects. So what can you do with this, and how do we offset the problems of not being able to put a breakpoint, not being able to measure coverage? So first of all, execution, right? It's the main thing, the main objective of this DSL. So we want to execute. Usually it's like this. So we have a number of rules. It's just a list of a rule, and we are just doing something. In our case, it's still one-liner, so it still works. But this is not the only thing that we can do with our DSL, because now our DSL, when it's being run, it builds an object model in memory. And this object model can be transpiled or can be represented in various ways. For example, we can visualize it. Well, if we speak about object-oriented design patterns, another pattern which is very useful here with traversing the objects is the visitor pattern, right? So we can make all the elements to implement some super interface with the visit method, and we can build just a simple traversal algorithm of all the elements. So one of the visitors may do the following: take our model and transpile it and output some other text in some other language, in some other DSL, for example. Let me run this example, and we'll see. So it must show in, yeah. So it shows in the browser. So what it actually did, it transpiled this code. Let me show it to you. This one, right? It just traversed it, and it transpiled into this code. So this is a code generated in what is called GraphViz language or dot language. And this GraphViz language is used for building, so you can compile this program into SVG or PNG, which will show you this picture. And this picture immediately shows to you all the intricacies, all the interactions of our conditions and transformations. So you can include it into your documentation, so it's live documentation. So it's not some some diagram created by someone in Notion or on a whiteboard, and then in 1 week it's outdated because we changed something, right? So it's self-describing documentation for your code, and a very visual one. And actually, this is the first thing that I always do with any DSL. Like if we have some, object model in our code, the first thing that is worth doing is, okay, let's dump it into GraphViz and see how it's done. Right. So I already mentioned documentation. Actually, another thing that can be done with your DSL is transpiling it into some documentation format. So what are, Markdown is, for example, is quite popular one, but I am personally a big fan of ASCII Doctor. Who uses ASCII Doctor? Who knows about ASCII Doctor? There must be more of you because it's way more powerful. It's like a Markdown. It's like at the first glance, it's like the same Markdown. The only difference is it's way more powerful. So you can include diagrams, you can include like very complicated tables in it, and actually it's a huge system and for building advanced documentation. So if I write this this script of transpiling my DSL into documentation, I will get this code. This dash. This means like header of the second level. You're familiar with Markdown, right? So this is, elements. So if I put this, just a moment. If I put this code into a specific, IDE, for example, or if I run Gradle transformation, I can get an HTML or PDF or web page with the definition of what's going on here. So actually, in the project that I'm currently developing, we have very extensive documentation, very extensive customer reference, and the large part of this reference is being auto-generated from the code itself. It's like Java doc, but only you define it yourself. So if you are building something really complex with lots of domain knowledge, with lots of intricate rules, you may think about, okay, let's put the documentation in the code and let's generate it out of your DSL. Of course, you can add some description parameters to your DSL objects and stuff and use it in the documentation. Okay. The next thing, and this is like the free option, which you automatically get with your DSL, is serialization. That's because your code now is just a set of objects, just an object model in memory. Since it's an object model in memory, you can serialize it into JSON, into YAML, for example. So serialization.kt. So what do we have here? In this case, it's just Jackson serializer. So no magic here. It's set up for YAML output. And if I run it, what do I get? I actually getting YAML DSL out of my Kotlin DSL for free. So YAML representation of my Kotlin DSL. So you see, like it's a condition, it's and like it contains like of two elements, and this is condition 1, condition 4. So there can be some parameters here as well. So where it can be useful, if you are writing, for example, user interface, which must be capable of visualizing of your layout, or if you are writing what is called by Martin Fowler in his book, a projectional editor. What is a projectional editor? It's an interface not with a text, it's not a text editor, but it's like an interface which consists of checkboxes, drop-downs, like whatever, where you can configure your DSL, configure your object model. So this is quite useful to be able to represent your object model into something familiar to front-end developers, namely JSON. So you can take JSON and take your object model and convert it to JSON and send it to front-end. And possibly, after some modification, you're getting this JSON back. Of course, you cannot deserialize JSON into Kotlin. That's limitation. But yeah, it all depends on the task that you solve. So as you can see, like having one thing, one source of truth in your code, you can produce many things: documentation, visualization, user interface, and execution themselves. So the main objective of your code. Okay, but how do you deal with testing it? It's a difficult question actually, and well, my answer for this, it must be solved like on per case basis. In our case, for example, what we did is a sanity test. The sanity test means that no rules must be unreachable. So if we take a close look at this example, so each rule here, written presumably by the domain expert, is meant to be executed in some circumstances, right? So if some of the rules are unreachable, just logically cannot be invoked in any case, this means we have a logical mistake here. Can we spot a logical mistake just by looking at this code? Probably not. But if we run a sanity test, which just checks all the possible combinations, so what does it do? So we have 4 conditions here, right? So it's 2 to the power of n like possibilities of these conditions, and it just checks like is it like what transformation it's running, like what rule is being invoked. So for 16, it's quite easy to verify them all, and we see that the following rules are unreachable: condition 1 and not condition 3. Condition 1 and not condition 3, it never gets invoked. And it's not easy to see why, but like we need to remember, I don't know, some mathematical logic from like university. So for this to be invoked, condition 1 must be true, right? So it must be true because like this needs to be invoked. So condition 1 must be true. So if condition 1 is true and condition 4 is false, then this rule is invoked. But if condition 1 is true and condition 4 is false, this one is invoked. So regardless of condition 4 is it true or false, when condition 1 is true, either this line or this line works, and this one never gets invoked. So if we comment out this line of the code, we will get a green test. And yeah, actually, as you can see, we have exponential growth, like combinatorial explosion and stuff, but still up to a dozen of conditions, it still perfectly works. So you can still write your brute force, tests for some sanity checks. So in my case, it was like no unreachable rules. For a fixed condition, every rule of a certain class is achievable and stuff like that. So we had like a number of verifications, and that helped us a lot to build sane DSLs. Okay, so that was the second part of my talk. And as you can see, when you have a DSL, which builds an object model for some like knowledge in your system, it can be used in execution, documentation, visualization, serialization for front end, for example, and it can be validated by static checks or specific tests. And by the way, like, are they fast or slow, these tests? So you may say, okay, it's exponential growth, they must be slow. But actually not. They're really fast because we are not actually invoking any transformation for this test. We are not like invoking calculation of conditions. So this can be tested separately. Each transformation can be a heavy task, right? So this is quite an isolated test, actually. Okay, now we are going to advanced topics of DSL building, and I remember that like it's only a couple of people in this room who are actually doing DSLs in Kotlin. So let me scroll it back to these 2 slides. So my suggestion to anybody who wants to learn Kotlin is this book, of course. Now they have second edition, which is much thicker than it used to be in the first one. So don't buy first edition, like buy second right away. And it's have like a whole chapter on Kotlin DSLs, and also very thick like section on unstructured concurrency. So it's really nice book. For those who prefer to watch videos, I recommend the series of Anton Arkhipov. So his Kotlin DSL in under an hour is a perfect example of live coding and building DSLs. But yeah, I'm going to show you some live coding and some like circumventing some limitations as well. So let's get to some advanced methods in Kotlin DSL. Well, first of all, the first trick is not actually like a big one. You still can mix and match DSL and imperative code in your DSLs. So if we look here, if we look at this code, at this example, once again, so you can see that conditions here are quite hard-coded. There are some objects. And probably if you give like your user, the user of your API, the choice, they can choose like among some of them. But you can get them the freedom by defining an extension point. For example, custom condition defined as a lambda. And now we can write something like, OK, let's write a non-deterministic condition which is going to be true in 88% of the cases. So in some other DSL, it can be some custom business rule. And in curly braces, we have some programmatical check. So it's a very powerful approach for modeling business rules, especially when DSL can capture only part of the logic. What do I mean here? Probably everybody, like at some point in their careers, wrote like state machines for states and transitions for some document or something like accepted, in progress, cancelled, rejected, and so on and so forth. So you can define a state machine like this set of transformations, for example, from I don't know, submitted, it can be transformed to, I don't know, in progress, but cannot be transformed to like rejected right away. It should come through in progress. But in reality, it's more complex than this, right? So there are various, fields, properties of your submissions, like your objects, and you want to write some imperative code here. So you can mix and match, and you can build your, DSLs and your state machines with this mix and match. But depending on context, it can be, of course, a good practice or a pitfall, because you may allow people or users of your DSL to script, and sometimes, of course, it gives you more power. Sometimes it's dangerous or just unwanted. So, annoying Kotlin limitation. That's really annoying me because I used to use Groovy DSL in Gradle. Now I mainly use Kotlin Gradle DSL. And if you are using it, you must notice this like annoying parenthesis there. If you want to pull in some dependency, for example, in your code. And why is it so? Like we have like DSL capabilities in our language. Why do we need this parenthesis? Well, first of all, Groovy. In Groovy, you are not obliged to write parentheses if a compiler can decide that this is a parameter of this function. So this is just a method call, and this is just a parameter. So you don't need. So you can if you want, but you don't need to. In Kotlin, it's more complicated. So let's see at this example. So this is a DSL which defines an agenda of a conference. And we see that quite a clean structure, right? So conference, it consists of sessions. Each session has a speaker. Some sessions, they have more than one speaker, and also a room. So lots of parentheses here. Can we get rid of them? Well, sometimes we can. For example, I can remove these parentheses. Why? Because in room is an infix fun. If I remove infix, then instantly I will have to get parentheses back, but I'm not doing this. And for infix functions, we can just remove parentheses, and they are just designed exactly for this. But can I remove parentheses here? Well, probably this function is not infix one. Let's have a look. No, it's infix as well. Why it's not working? That's because in this case, in room is called on the result of invocation of this call, but speaker is invoked on the implicit this. So I can write it like this, and there will be no parentheses, but it's going to be this speaker, this speaker, this speaker. In our DSL, probably this is not what we want. So infix does not always work in Kotlin, unfortunately. And this is why in Gradle DSL you have your implementation parentheses, test implementation parentheses. So how can we do better? Well, actually in Kotlin you can override unary operators. For example, you can override the plus operator and write it like this. And do it. So no parentheses are needed. So it's only a plus. And if you control-click, you will see that it's operator fun unary plus, which is just a shortcut for speaker method. But we can easily imagine if I replace all the sessions with pluses, all the speakers with pluses, or I don't know, all the sessions with pluses and all the speakers with unary minuses, well, in a way, it's going to be a cleaner DSL, but in some other way, it will be more perplexing, right? So you don't know like which is speaker, which is session, which is meant by what. So again, it's up to you to decide, but we have what we have in Kotlin. Parentheses are not always like you are not always able to get rid of them. The next thing, which is a must, I think, when you are writing your DSLs, is the following. Oh, let me just get back to session and speaker for this example to be cleaner. So what we are writing here, like from the point of view of Kotlin syntax, is called a lambda with receiver. So if you don't yet know what it is, just read about it. It's quite simple concept. But this means that within this lambda, we have some context, right? We have some implicit this. In this case, it's conference builder. When we go into a session, the implicit this is speakers builder. But also, all the methods from conference builder are available by default in Kotlin, so I can set a session within a session. Probably this is not that I would like to allow in our DSL. This is something which doesn't make sense. So I would like to prohibit this. How do I do this? For this, in Kotlin specifically, they have the magical annotation called DSL marker. So the suggested pattern is the following. So you do DSL marker, you create your own annotation, and you mark with this annotation all the builders, all the definitions for your code. So let's go here. Immediately, the code won't compile. Now it's not permitted. And I don't know if you noticed or not, IntelliJ IDEA now highlights the code in a slightly different way. IntelliJ IDEA now knows that we are working with DSL, not with normal Kotlin code here. So this feature of so it is known that this feature is used by JetBrains in their IDE. So it like has some magic which will simplify for you work with DSLs. It's not documented, but the rule of thumb, I suppose, like every time you are creating your Kotlin DSLs, please do not forget about this add DSL marker. It just will make your life easier and more sense with your code. Cool. Let's move further. Another limitation of working with statically typed language. Sometimes we have one speaker which participates in more than one session. So how do we make it? Of course, we can create speaker multiple times, but we want to reuse it. So all that is left in our case is create a value, assign it to it, and reuse it. Well, I'm not very happy with this code. For example, in Groovy, I could have something like new speaker like MJ and blah, blah, blah. And then I can refer to MJ later in Groovy. Because in Groovy, I can dynamically handle new unknown identifiers. I can in runtime, I can work with them. In Kotlin, this is not possible. In Kotlin, you should use the Kotlin syntax here. Thus, your code will look more like imperative one. Unfortunately, this is something that you cannot fully avoid, but there is one advanced trick which will allow you to get something out of this. If we go to this example, so in this example, we decided to add to a speaker entity, IP1, to a speaker entity one more field, identifier. So we have name, we have organization, and we have an identifier. So if we continue to use it like we did before, we can create another speaker with some other variable, with some other name, probably the same organization, that's not forbidden, but with the same identifier. But we want identifiers to be unique, right? And we want to refer to them. So what people are doing with Kotlin, they are using the delegation pattern, the by keyword for this. So let's see how it's going to work. So if I'm running like this code, we're defining this variable, but this variable is not assigned, it's delegated to some property. So here the speaker method is some function which must obey some agreement, some contract that it's a read-only property, and within its implementation we have an access, a reflective access to the property itself. Thus, we can extract the name of the variable that we are assigning to. So let me run this, and it will become obvious for you. So if I run this code, I will have some dump of my structure, and you see the ID is IP here, but where does this IP comes from? It comes from the name of this variable. And now it is prohibited to create two speakers with the same identifier just because Kotlin prohibits to create two variables with the same name. So this is quite powerful thing, and yeah, if you want cross references within your DSL, you cannot avoid this val, you cannot avoid this imperative looking code. First of all, you cannot avoid val, unfortunately, but you can leverage this one. And finally, the final trick that I wanted to show to you, it's invoke. So far, our conference method was a function, right? So it's a function which takes a lambda as a single interface, as a single argument. So you're writing conference, then open curly brace, and so on and so forth. What you actually can do is in Kotlin is like this: conference.name, and then define this this content of the conference. So in Gradle DSL, you will definitely see something like task dot something or task and curly braces. So what's the trick here? Quite simple. Now, conference is not a function. It is an object. It is an object. But in every object, we can define an invoke operator. And this invoke operator will work as invocable object. So you write your object name and then parentheses, and by parentheses, you are calling the invoke operator. If this invoke operator takes a lambda as a parameter, you can omit parentheses, you can go to curly braces straight away. So by using the invoke operator, you can define your DSLs like this. So let us wrap up. Cross references, capturing the variable name, and invoke operator. There is a number of examples for your inspiration if you want to write Kotlin DSLs. So the simplest one is the Kotlin XML builder. I think the name says for itself. So you just writing your XML structure, but only with curly braces and stuff. The next very nice one is the DSL is called KT, DSL for command line parameters parsing. Of course, Kotlin Gradle Kotlin DSL if you are using Gradle. My suggestion, forget about Groovy. Use Kotlin because it's statically typed. You will get your errors earlier within your DSL and more support from the IDE. KTOR framework, and I promise that there won't be any AI in my talk, but recently JetBrains released the Cook framework. Who heard about Cook framework? Not yet? So it's a framework for building AI agents, actually. And it's built on the basis of Kotlin DSL. So they have very extensive, very nice Kotlin DSL to build the network of transformations of invocations of LLM and stuff. So this can also be an example for your inspiration. Okay, conclusions. So DSL combined with design patterns, strategy, visitor, what else? Is a powerful tool for solving multiple tasks. Creating DSLs in Kotlin is not scary. You can improve parts of your existing internal APIs today, making them DSL-ish. Actually, just add, for example, infix to some function. Think about introducing some operators. And you will see that your code will look nicer. Just your Kotlin code will look more DSL-ish. Internal Kotlin DSLs are not the only way to implement DSLs. Always remember, you have other options. But definitely, it's not the worst one in many scenarios. So everything I showed to you is available on GitHub. Slides as well. I'm using slides as code. They're compiled from source code. So yeah, you can go there, drop me a line, find me on LinkedIn. Thank you very much for your attention.